Now let's talk about unfolding cones and cylinders. A male ant is at A, at the bottom of the cylinder, and sees a beautiful female ant directly above at B, at the top of the cylinder. The cylinder has a height of 3 and a circumference of 4. The male ant crawls completely around the cylinder to B. What is the shortest distance it must travel to get to the female ant? So basically we have this ant and it's going to crawl all the way around to get up to B. So what does this really look like? We're now going to be talking about the lateral surface area. We're not going to be worrying about the top or the bottom at all. So it's kind of like taking our soup can and peeling off the label. When we spread that label out to flatten it, we actually have a rectangle. So if we imagine this as a label that's going all the way around, that would be like our lateral surface area. So we would have A here in the corner and B straight above, but the ant doesn't want to just crawl straight up. It's going to crawl all the way around instead. But since we cut our label right here at A and B, this side is actually going to connect to A. So we're going to call that A prime, and at the top would be B prime. It pretty much connects right back to this same point, so it doesn't matter which of these B's he goes to. So the quickest distance to get from A to B would be to make a diagonal here. So what's the distance of that diagonal? Well, the cylinder has a height of 3, so we can say that the height of this rectangle is 3, and a circumference of 4, which means that the length of this rectangle is 4. So how do we find that third line? We're going to use the Pythagorean theorem. We're going to say that we have 3 squared plus 4 squared is going to equal x squared, where x is the hypotenuse of our triangle here. So 3 squared is 9 plus 4 squared is 16, and that equals 25. And the square root of 25 will be x. So the square root of 25 equals x, which equals 5. So the distance he's going to have to travel is 5 meters.